Hello, my amazing students. This is Mrs. A, and we are doing 4.4, which is linear and compound linear inequalities in two variables. Okay, so we're going to start with a problem. Anytime we're graphing inequalities, we want to first graph the associated line. So even though this 2x plus 3y is less than or equal to negative 9 is what we want to graph, the first thing we want to graph is the line 2x plus 3y equals negative 9. If we can't graph the line, we certainly won't get the inequality graphed correctly. So basically, the steps for graphing an inequality is to first graph the boundary line here. If this expression, less than or equal to, has an equal sign in it, which it does, then our line will be solid. If it only has a less than or a greater than, then our line will be dashed. Okay, so we have to decide what kind of boundary line we're going to have. If there's a little equal there, it means that the line itself is part of the solution. If there's not a little equal there, it means that the boundary line is exactly that. It's a boundary to the solution set, but no part of the line is actually a solution to the inequality. And then lastly, we will have to shade. And to do that, we will find a test point. We usually use 0, 0 as a very easy test point if it is not on the line that we're graphing. So in order to graph this equality, we will do it two ways because I want you to be familiar with both ways. Anytime we have something in standard form, it's very easy to graph it using the x and y intercept. To find the x-intercept, we let y be 0. So if I cover up the y value with my finger, then I have 2x. Well, we're really doing this one down here. We're doing the equality, aren't we? We're going to cover up the y. 2x equals negative 9, which means that x equals negative 4.5. Okay, so x is negative 4.5, and that will be my x-intercept. To find the y-intercept, I let x be 0. To find the y-intercept, I let x be 0. So if I cover up the x with my finger, then I get 3y is negative 9, or divide by 3 on both sides, I get y is negative 3. Okay, so y is negative 3 is the y-intercept. Now you can see over here that on the x-axis I have graphed negative 4.5, and on the y-axis I have graphed negative 3. So my line will go through those 2 points. Okay, the other way to easily graph a line is to figure out what is its slope and y-intercept. Okay, it's in standard form. So remember the little shortcut I taught you, that the slope is negative a over b. The a is your x term, your b is your y term. Negative a over b will be negative 2/3. So the slope is negative 2/3. And the y-intercept is c over b, which will be the little b is our y-intercept, and it will be negative 9 over 3, which is negative 3. Okay, now if I start at a y-intercept of negative 3, and then I go down 2 and over 3, guess what happens? I start at negative 3, and I go down 2 and over 3, 1, 2, 3, or up 2 and back 3, 1, 2, 3. I wind up on this line. Of course, it would work better if I had graph paper, which I don't right now. But my line is going to go through those points. Okay, so that's two ways to graph your boundary line. So now that I have graphed my boundary line, I have to look back at my inequality, which I have up here, and I decide, yes, mine has an equal to it. So I'm going to have a solid line. Now comes this shading of the line. I need to know whether to shade above my boundary line or below it. I'm going to pick the easiest test point, which is 0, 0, because 0, 0 is not on my line, and therefore I can use it as a test point. If 0, 0 makes my inequality true, then I will shade towards 0, 0. If 0, 0 does not make my inequality true, then I will shade away from 0, 0. So I plug in a 0 and a 0, and 2 times 0 plus 3 times 0 is 0. Is 0 less than a negative 9? And the answer is no. So 0 does not make my inequality true. 0, 0 is not a good point. Therefore, I will shade away from 0, 0. Okay? All right, so now we're going to graph another inequality. Negative 2x plus y is greater than 1. So first I'm going to graph the associated line, which is negative 2x plus y equals 1. And I'm going to do it both ways so that you become familiar with both of these methods. So first we're going to find the x and the y-intercept. Okay, to find the y-intercept, I let x be 0. If I put my finger over the x, then I get y is 1. Okay, so y is 1. That's the y-intercept. And to find the x-intercept, I let the y be 0. And I get negative 2x is equal to 1, or x is equal to negative 1/2. All right, so my y-intercept is 1. So I'll put a point on 1. My x, oops, it was negative 1/2, wasn't it? I didn't write that correctly. Yes, negative 1/2. So the x-intercept is negative 1/2, so I'll put a little point there with the negative 1/2. Okay, the other method is to find your slope and your y-intercept. If I look at those two, negative a over b is my slope, and negative a would be positive 2 over 1. So my slope is 2, and my y-intercept is, well, I already figured it out, didn't I? I figured out my y-intercept is 1. So my b is 1. So now, if I had looked at it with this, 1 over 1, c over b, 1 over 1 is 1. All right, I found it both ways. So now, if I start at my y-intercept of 1 and I go up 2 over 1, then I'm going to go up 2 over 1, and there's another point. And my line here is going to be a dashed line. So I'm going to go ahead and make my line dashed here, showing that the line is not part of the solution. Okay, so then I have to figure out which way to shade that line. 0, 0 is not on the line, so 0, 0 is going to be my little test point. If I plug in a 0 and a 0, I get a 0 on the left is greater than 1, but we know 0 is not greater than 1. So we will shade away from 0, 0. So our shading will be above the line. Okay, so now this one is already in slope-intercept form. So we're going to go ahead and graph it using our slope-intercept form only. So we've got an intercept, y-intercept of negative 2, which shows it will be there. And my slope is up 3 over 4. Up 3 over 4. So 1, 2, 3, 1, 2, 3, 4. So we can graph. And is our line going to be solid or dashed? Since we don't have an equal sign there, it will be dashed. Okay, so we make a little dashed line, and then we plug in 0, 0 again is not on our line. So we'll plug in 0 here and a 0 here, and we wind up getting 0 is less than a negative 2. and 0 is not less than a negative 2. Therefore, we will again shade away from 0, 0. Now, sometimes 0, 0 does make it true, so that's not going to always be the case, okay? And we have this one, okay? So since this is in our standard form, we will do it two ways. To find the y-intercept, I cover up the x term, and I get negative y is equal to 4, and so that means that y is equal to negative 4. So my y-intercept is equal to negative 4, and if I cover up my y, then I get 3x is equal to 4, or x is 4/3. So if I graph those 2 points, my y-intercept is negative 4. 1, 2, 3, 4. It's down at the very bottom of my graph, okay? So this point, and then I graph my x-intercept. 4/3 is 1 1/3. So maybe just right about there, okay? So my line would be running, and my line here would be solid line. So here's my line. Okay, now let's graph it the other way. Remember, our slope here is negative a over b. Our slope is negative a over b. Since I've got a negative 3 over a negative 1, my slope is a positive 3. Our slope is climbing, so it looks right. And our y-intercept is c over b. And c is 4, b is negative 1, so we get a negative 4. So our little b, our y-intercept, is negative 4, which is exactly what we got before when we were doing that. So we start at negative 4, and we go up 3, 1, 2, 3 over 1, 1, 2, 3 over 1, and it looks like we're doing well with our line. It is solid, and we again can pick 0, 0. If we plug in 0, 0, we get 0 on the left is less than 4. This time it's true. 0 is less than 4. So we will shade towards 0, 0. And now I will be back momentarily with some compound inequalities. That's when we put two of them together with ands or ors. So we're coming back for that one.